today what I'm going to do is I'm just going to give you a brief overview about your big data, not even Hadoop. Okay, how exactly the relationship between the big data and Hadoop, how this particular Hadoop and big data is going to satisfy the existing data requirements in terms of storage and processing. These are all the things that we are going to discuss today. So right now, one thing is we are existing in two types of systems. Okay, first type of systems are nothing but your OLTP systems, called as the online transaction processing systems, and you have another type of systems called as this OLAP, which is nothing but your, and this is meant for your reporting and analysis. Okay. Now, can anybody tell me what is the maximum amount of data that you can use in the systems? What is the maximum amount of data that you might have seen? Is it a gigabyte or a terabyte or petabyte, something of that sort? In the current scenario, an average company will be able to store either at a max of 500 gigabytes to 1 terabyte of data online. 500 gigabytes to 1 terabyte. Okay, or else in case if you take a very massive scale company, it can have the option of storing this particular 10 terabytes of data. That's it. Either in these OLTP systems or in the OLAP systems. This is the requirement that you are having here. This is the current requirement that you are having here in this particular case. Okay. Now, one thing that you need to really understand here is data at any point of time is rapidly growing in size. Guys, do you agree with me? Raskiran or Nanda or Krishna, do you agree with me? Data is rapidly growing in size.
Yeah. Yes, Ravi. That's true.
Yeah. In what way the data is growing? You can see here. Day by day, what is happening is social networking, Twitters, okay, or else the retail systems, the banking systems, the sensors. These are all the systems that will try to generate some massive amounts of data, right? So how can you say here? Earlier in these OLTP systems and in the OLAP systems, you have only one type of data, and the type of data is generated as the structured data, right? The type of data what you're having here is generated as the structured data. So your structured data is always existing in the form of tables. Your structured data what you're having here is always existing in the form of tables here. Okay, but now what is happening is nowadays you are going to have three types of data that exist. What are those three types of data? Those three types of data is nothing but your structured. Okay, it might be your semi-structured, as well as it might be your unstructured data also as well. Unstructured data that is being generated. So now when all this particular data is being generated, guys, can you tell me whether we need to store this data or there is no need for us to store this data? We have to store this data. Okay, when you want to have to store this particular data, okay, one question what I'm asking is that will you be able to store all this particular data in a single database or a single system? Guys, will you be able to store all this data in a single system?
Yeah, if you store, generally the processing time will be more. And it's a huge amount of the data. So
this is huge amount of data. That means that what happens is that the amount of data is exploding, right? Exploding. It is not even gigabytes, it is terabytes, petabytes, zettabytes, and yottabytes also as well. The data is exploding. So that's why what happens is you may not be able to store this particular data in a single system. You may not be able to store this data in a single system, but instead what you're expected to have is that you're expected to have a cluster of systems. A cluster of systems that are required to store this particular data, right? A cluster of systems that are required to store this particular data. So in such a case, what do we call this particular cluster of systems? what do we call these cluster of systems? This cluster of systems is generally treated as the distributed network, right? This cluster of systems is generally treated as the distributed network here. Okay, now within this distributed network, what is something that we are going to store is we are going to store not only your data, but also what we need to do. Do we need to process the data also as well? Okay, so guys, can you tell me? For the purpose of storing this particular data here, do we need to process the data or not, Jay? Hello?
Yeah, sorry.
Do we need to process this data or not?
Different. Without processing data, we cannot get meaningful information.
Yeah, we'll not be able to get that meaningful information, right? So that's why what has to be done is that one thing is that you need to store the data as well as you need to process the data. Okay. Third thing what you are having here is that you need to analyze that particular data also as well. So there are three different aspects that you need to do. One is in terms of storage you need to have. Okay. The second thing is in terms of processing you need to have. This is nothing but your process that you need to have. Okay. And the other thing what you need to do is that you should have the option of analyzing that particular data also. You need to analyze that data. So that is the reason what happens is that any data that you are having here is subjected with three types of things. One is trying to store the data along with trying to process the data, as well as we need to analyze this particular data also as well. So that's why this particular big data concept is coming. The reason that is coming here is as data is exploding, what happens is that the existing systems in terms of OLTP and OLAP may not be in a position to store the total amount of data. But in such a case, what you need to do is that you need to shift to altogether a new technology. That new technology is nothing but the distributed network. That new technology is nothing but the distributed network. And within this distributed network, what we need to do is we need to process as well as we need to store this particular data also as well, right? We need to process as well as we need to store this particular data also as well. So this is what is happening here. So if you want to see these things in action, I'll tell you here. You can see it like this. How exactly it is going to define the things here. Data volume is increasing. How it is increasing here? It is increasing exponentially. We were in 2000 talking in terms of terabytes, okay, but you are having this petabytes of data, exabytes of data, as well as zettabytes of data that is being generated day by day. Okay, so data volume is increasing exponentially. Okay, when data volume is increasing, obviously what you need to have? You need to have the storage where the data has to be stored. You need to have the storage where the data has to be stored. So that's why you might be asking how such type of data is being generated. As I have told you, right, you can have the data that can be generated in the form of your social networking. You have the data that can be generated in the form of Twitter's, streaming of data, Google satellites. In all these particular systems, you are getting this data. But I told you that there are three types of data. What are the three types of data? One is the structured, semi-structured, as well as unstructured data also as well. All this social media data, multi-dimensional array, streaming data is generally treated as this unstructured data in this particular case here. Okay, it generally treated as the unstructured data here. Now, to extract this particular data, all this data need to be linked together, right? I would like to link all this particular data. So I need to store this particular data. But what is happening here? The data is being generated, but at what pace? The data is being generated at an extreme fast pace. The data is being generated. So that is what is called as the velocity. So when the data is being generated at that particular pace, and in case if you are not responding to that particular data without processing and analyzing, what you're going to have is that the late decisions are going to be these particular missing opportunities that you're going to have here. Late decisions are going to be the missing opportunities that you're going to have. The example is when you try to do some eBay promotions and all, automatically what happens? You have a bid that is going on where you need to take a decision within some 5 to 10 minutes, and within that time, if you don't take, some party will come and then grab that particular piece. That is not critical, but health monitoring systems, whenever you take, especially whenever you're having an high emergency patient where you need to monitor his health stats, automatically, spontaneously, you need to take the decisions. So obviously what you need to have is that you have the data, based on this particular data, you need to store the data, you need to process as well as you need to analyze that particular data also as well. So that is the reason what happens is you're going to have three types of data. One is the data which is having large volume, which is having the large velocity along with the large variety of data here. So that's why big data is something which is characterized by three values. One is velocity, the second one is volume, and third one is variety in this particular case here. Variety in this particular case. Okay. Now, one thing that we need to understand here is, see here, right? It started with megabytes, gigabytes, terabytes, along with your petabytes also as well. Okay. Now, we understood big data is in terms of volume, in terms of variety, in terms of velocity, we have understood. Okay. But one thing that we don't understand is that we should have some systems where we can store this particular data. Okay. But you know, guys, like what are the existing type of systems what you're having? The existing systems what you're having here is Naresh or Nanda or Kishore, Krishna. You know that the existing systems what you're having is there are only two types of system. One is the transactional system and second thing is the analytical system, right? Transactional systems and analytical systems. Naresh?
Yeah. That's
so. Do you think that those transactional and analytical systems will be sufficient to accommodate this particular data?
No.
No. The reason is they are not in a position to accommodate that particular data. That is the reason what we are having is we are trying to depend on some other type of system, okay, that will try to have the storage for this particular large data sets for the purpose of processing as well as for the purpose of analyzing this particular data. Okay, so such type of large data sets are generated as big data sets. Such type of large data sets what you're having here are generated as big data sets in this particular case. You understood, guys? What is the necessity of this particular big data to be arrived in this particular market?
Yep.
Any questions so far? See here, big data is the amount of data that is beyond the storage and processing capacity of a single machine, right? We cannot have a single machine that can store all this particular data. So that's why the data that has large volume comes from variety of sources that comes up with a great velocity is referred to as this particular big data here, right? Okay, now when I have told you that a single system itself will not be able to store when a single system is not in a position to store such type of data, obviously what we need to have is that you need to have some other systems that we need to use. Okay, the other systems what you're having here are nothing but your distributed systems, basically. Distributed systems. Have anybody heard about these distributed systems? Distributed systems? Guys, the thing what I'm talking about here is your distributed system. Within this distributed system, what you're having here is you have the application servers that exist. These are the clients that are aimed at processing that particular data. Applications which process your data. But where is your data? The data is existing within your storage servers here. The data is existing within your storage servers. Okay. Now what happens is that your data is residing here and these applications will process this data. Okay, now what should happen is this data has to pass through this particular network for the purpose of reaching the application server, for processing. So that means that what is happening here, programs run on each application server. All the data is on the storage area network. Before execution, every server gets the data from SAN. After execution, every server writes the output back to this storage area network. This is how the typical distribution systems are existing. What are the typical distributed systems? You might talk about your NFS, which is nothing but the network file system, or else you might talk about your SAN also as well, which is nothing but the storage area network. You can also talk about SAN also as well. Okay, but now the problem is with this network, we are having so many problems. Guys, can anybody tell me, when you take a program and when you take the data, which occupies more storage? Does the program occupy more storage or the data occupies more storage?
Data.
Data occupies more storage. But here, what is happening here? Generally, do you expect programs to go to the data or data to come to the programs?
Normally, in the typical traditional, the data passes through the programs.
The data should pass through the programs. But here, what is happening here? Your storage area network, assuming that it is of 100 megabytes or something like 500 megabytes per second. Okay. Now, when you want to pass something like 50 gigabytes of data or 100 gigabytes of data, don't you think that it is going to tax the resources of the storage area network, guys? It is going to tax the resources, right? Okay. Yes. So that means that if you want to add one more storage area network here, one more storage server, do you think that the existing network bandwidth will support that one? It will not support, right?
Yep. It will be difficult, yeah.
It will be difficult. So in such a case, what we do say here, don't you say that scaling up and down is not a smooth process? Don't you think that scaling up and down is not a smooth process at any point of time? We cannot scale up the systems here. And another thing, suppose if this disk crashes in terms of processing, what will you do? If the disk crashes in the middle, what you need to do? You need to bring your processing entirely to the halt, right? You need to bring your processing entirely to the halt. Okay. Yeah.
We need to halt and also take a backup, which is going to be a lengthy process.
Yeah. We need to bring this particular process entirely to a halt. Okay. In such a case, what happens is there is no failure capability also as well. Okay. And third thing is application servers and storage servers might be existing in different protocols altogether. Maybe existing in different protocols. When you say that they're existing in different protocols, what does it mean? This might be working on Unix as well as this might be working on Linux, something of that sort. Okay. In such a case, do you think that you'll be able to get the protocol information between these two things? You'll not be able to do, right? That is because of this synchronization problem. You'll not be able to exchange the information here. Right, guys?
Right. Yeah.
Synchronization problem is going to exist here. Okay. So these are all the problems with respect to your typical distributed systems. Guys, one thing that you need to understand here is even before the invention of this big data also as well, your data for the entire organization was not stored in a single system, but it has been stored in multiple collection of systems, which is treated as a cluster. Okay. Now one thing what we need to do is that in such type of cluster, if you really want to store that particular data, if you really want to store this particular data and process, these are all the problems that you're having here. What are the problems you can see here? Huge dependency of network and huge bandwidth demands. This is the first problem that you're having here. Yeah, what I'm saying is scaling up and down is not a smooth process. Third thing, what I told you, partial failures are difficult to handle, right? And one more thing is that a lot of processing power is utilized in transmitting the data, right? Generally, we expect the data to be transferred to the programs, which is an unfair process here. But because when data is getting transmitted to the programs, it is going to consume a lot of resources over the network, which is not always a viable process. That is the reason what we need to do is that we expect big data to handle in such a way that programs can be passed to the data, but not the data to be processed to the programs in this particular case. And another thing is that I have told you, data synchronization is required during exchange. Okay, these are all the problems with respect to the typical distributed systems what you are having as of today. That is reason what we are having is in order to address these particular challenges, okay, and in order to have a new innovation that need to happen in terms of storing, processing, and analyzing that particular data, that is the place where big data is expected to pitch in. That is the place where big data is expected to pitch in. Guys, now you understand what I'm talking about.
Right. Yeah.
Can you summarize now what we are talking? You see, honestly, there is a lot of disturbance that is happening here, but I just want to give you the teasers of big data here. One thing is, we are living in a digital age. What is the digital age? A Facebook or Twitter or any other social networking site, whatever you take. Nowadays, what is happening is, even when we try to face each other, we really don't know whether we talk to each other or not. But what happens is that, for sure, you will be talking on the Facebook. You will be liking, disliking, sharing, and everything you will be doing. So that means that almost your life is totally inclined with respect to the social networking right now. So that is the reason, whatever your thought process that you are having or whatever the articulation that you make, it is not by using your mindset, but that is the digital age has totally influenced your life. Not only influencing your life, it also has influenced the entire IT industry as well as the entire organizations of different verticals also as well. Okay, that is the reason what is happening is that there are emerging so many megabytes, gigabytes, terabytes, petabytes of data here. Okay, gigabytes is totally gone at any point of time. There is no place where you have this particular gigabytes of data. Gigabytes of data is totally gone. Whatever you are having here is petabytes of data here. Okay, so in such a case, what you want to do, if you want to process your data, if you want to process your data, there are multiple sources from which your data is being generated, right? So if you want to really understand, you can look it like this. Who is generating the data here? You can see here. Social media is generating the data. Scientific instruments are generating the data. Mobile devices, sensors is already generating the data here. Earlier is few companies are generating the data and all others are consuming the data. Now what is happening here? Everybody is generating the data and everybody would like to consume this particular data. So as a result, the existing infrastructure was not able to support your process altogether. That is the reason the industries are looking for a new architecture here. Business intelligence is gone. Okay, ad hoc coding and reporting is being done with the help of your normal data warehousing technology, including HANA. Okay, but when you want to go beyond that one, that is a place where your big data is expected to pitch in here. Optimizations and predictive analysis, complete statistical analysis, all types of data, very large data sets, and more of a real time. These are all the things that are expected to happen here. Okay, and what is happening here? Big data is more than real time in nature than traditional DW applications. It is nothing but a shared nothing, massive parallel architecture as well as suited for your big data applications. Okay. So what technology we need to use for big data? There are so many technologies that you're having here, and out of those technologies, the thing that we are going to talk about is nothing but your Hadoop. Okay, so let me ask you some straight questions so that please try to answer me here. Okay, especially Jay, Krishna, Nanda, Naresh, and all these particular guys. Please try to answer the questions. What are the major 3 activities that we do within any data processing algorithm? Tell me. What are the 3 activities that we do?
We store, process, and then we do the analytical reporting.
First one is store, second one is process, and third one is analysis, right? These are the 3 things that we do.
Right.
Okay. Can we do all? So in the traditional systems, what are the technologies that are being used? One is the OLTP system and second thing is the OLAP systems, right? Now, what are the driving factors that are motivating us to go to this particular big data?
The bottlenecks what we are seeing is scaling up and down, or that are a large amount of the traffic on the network, what we are trying to do, and then process huge amount of the data, all these things. Right?
Yeah. These are all the things that are acting as the showstoppers in order to go ahead with respect to the existing technologies. That is the reason what has come up is this big data has come into the picture. This big data has come into the picture. Okay, so what we can, how do we define this particular big data? Big data is defined as a collection of large data sets. A collection of large data sets that need to be stored as well as that need to be analyzed. Okay, which cannot be done with the help of your existing existing landscape or existing technology. That is the reason we want to have a special type of distributed computing systems that will have the capability to store the data as well as that will have the capability to process that particular data. So those are the things that we expect in this particular paradigm here. Okay.
Yep.
Any questions, guys? I have one person who is from SAP HANA. Who is that person?
Yeah, it's Krishna. Yeah.
Hi, Krishna. You also have the same problem with respect to HANA, right? Even in BW also, as well as even in ERP systems also, you are being limited by the volume of the data. So in order to have the massive applications, in order to process your data in memory only, what you are doing is that you want to have your instant memory or database that exists within the RAM that can hold that particular data. That is the reason people are going for that HANA basically, right?
Right, yeah. And one more thing which I just mentioned, I think rest did not join. The point in our company, what we are looking is the HANA database is a costlier database. So like with the distributed, it is a cheaper. So what is our thought is like, okay, if you are looking for analytical data which is for 1 or 2 years, let us use HANA. Rest of the data, why can't we push into Hadoop so that if required, we can do the reporting on older data and the current data, but still you will save money on storage of data.
Yeah. So with respect to the course, what we are going to do is that we are going to talk about Hadoop. We are going to talk about Hadoop is having two major components. One is nothing but HDFS that talks about your storage, and second thing is the Mapreduce that talks about your processing of data. Okay, we'll talk about all these particular ecosystems. I'll tell you what are the ecosystems that we are talking about here.
Ravi, before you go ahead, can you just give some details on the previous slide? I was no, not on the previous, which is having all the analytical infrastructure and all those different logos.
This one?
Yeah. Why I was a bit interested is like I'm trying to look some of the information. So now the Hadoop is, one is like I'm trying to understand, is it just hardware? The second thing is, yes, it can be installed on cloud. So Cloudera and Hortonworks, these are the two different sites which I just went across to see from yesterday, right? So because we are more about analytical infrastructure that we wanted to develop, so I thought like those things might be helpful for me to create some POC kind of thing. So that's where I was a bit interested on this slide, if you can throw some information on it.
See, let me tell you two things here.
Yep.
Okay. First thing is, whenever Cloudera and Horton networks are the distributions. Just like when you have a database, Oracle is the implementation vendor and Microsoft is the implementation vendor in the name of SQL Server, right? Basically, similarly, for the purpose of taking this particular Hadoop concept to the user community, there are a couple of companies that have come up here. Okay, these particular companies, the various distributions what you're having here are Cloudera is there, Hotter Networks is there, Mapr is there, okay, Microsoft Azure is there, Amazon Web Services is there. These are all the things. These are all the things that are existing basically. Okay. And each and every distribution comes up with some types of things. One thing comes up as a platform as a service. Okay. And second thing is a data as a service, operating system as a service. Like that, they generally come up with. Okay. So analytics as a service, like that, they come up with. So that means that what is happening is that their expertise, or else their landscape is spread across multiple platforms like this. They are spread across this particular multiple platforms. Okay, so this Hadoop, this Mapreduce or this Mapout, what you're having here, this is the base. Okay, on this particular base, what you're having here is that you're going to build up your operational infrastructure. You're going to build your infrastructure as a service, IaaS, PaaS, IaaS, and then PaaS. These things will do. So these are all the things that you need to really look into. These are all the things that we need to really look into for the purpose of taking this particular arena basically. So it's not only talking about Hadoop, it is talking about the various ecosystems that surround this particular Hadoop in order to take it to the next level basically, Krishna.
Okay, that's great. Thank you. Yeah.
Okay. So earlier we talked about all this business intelligence which is gone. Okay. We talk about visual analytics, which is also gone. Okay, this business intelligence and this one we're talking about in terms of your Oracle database, SQL Server database, and all those particular things. Okay, now what is happening here? All these things, using this particular technologies also as well, they are pointing to this particular Hadoop, which is going to act as the base for the purpose of doing your technologies. Okay.
Okay, yeah.
Okay, one thing, this is similar to your situation also as well here. You guys doesn't want to decommission HANA, but what you want to do, the more hot analytical information will be available in HANA, and what are the other set of information what you're having here, you would like to migrate it to other databases, right? In terms of big data and all, that is what is your company is planning here. Here also, we have lived with this particular technologies like Informatica, business objects, MicroStrategy and all since a couple of decades. Since the invention of big data, we really don't want to throw that particular technologies altogether. We still want to execute them, and we want to still leverage those particular experience in using this particular infrastructure. So that is the reason what has been done is that Hadoop has been generalized in terms of it can be used as a data processing language. It can be used as a, what is the next one? It can be used as a analytical language. It can also be used as a storage platform, as well as it can also be used as an infrastructure as a service also as well. So that's why this big data landscape is going to provide you all those particular flavors, not limited only for the purpose of storing and processing your data. That's why this particular landscape has come into the picture, Krishna. Okay.
Okay. Great.
Yeah.
Thank you.
So that is the reason what we are not going to discuss is that we really don't discuss something like I'll take up this particular curriculum, and within this particular curriculum I'll go content by content and itemized by item discussion. This is something that I don't discuss. I discuss everything practically. I'll discuss everything which is more of a real-time point of view and which is thought-provoking, that makes you to feel comfortable. Okay. In terms of implementing your practical solves as well. You'll be given the sandboxes, you'll be given all and each and every application that you're expected to work on, as well as you will also be provided with the lectures, the Java-based classes also will be provided in order to make you feel comfortable with respect to your Hadoop language here. Okay, Hadoop systems here. And another thing is that in this session, in this curriculum, we are not going to only discuss developer module. We are also going to discuss your PIG analytical modules also as well, Krishna. We'll be very much focusing on PIG, will be very much focusing on Hive and HBase also as well. HBase is something like to HANA. In HANA, what we generally do, is that we generally use that one as an in-memory database, right? In-columnar database. So similar to that one is nothing but your HANA that we are going to discuss here in the form of your HBase. Okay. We'll be discussing this particular Hive, which is nothing but a query language. We'll be discussing something like Scoop and Woozy, which will be used to import and export the data from one platform to another. All those particular things we are going to discuss. Okay. The total sessions itself, I'm trying to show you some maps here. Just like your Yahoo Play Store, you are going to have some apps, right? Okay.
Right.
Like you are also have something called as Hadoop App Store is there here. You are seeing here, right? Do you know anything in this one? HDFS, Mapreduce, HBase is like HANA, and Hive is nothing but the query language, and this one is nothing but your scripting language. Pig is nothing but your script language. Ambari, Avro, and all those things, Woozy and Scoop, these are nothing but your Woozy and Scoop are basically used for your workflow collaboration, and this is basically used for import and export of data from relational databases into Hadoop. Okay, and we talk about this particular mapper. We talk about your scripting languages. Okay, we'll be touching almost each and every app, maybe at a broader length or else maybe at a detailed length. But in the first line, whatever you are seeing here, till HBase, everything is going to be dealt in and out. Everything is going to be dealt in and out. You'll also be seeing HANA also as well here, basically, right?
Yeah, right.
So see here, Apache Hadoop we are going to discuss. We are going to discuss about your Hadoop distributions. We are going to talk about your big data suites also as well. Okay. In terms of what we are going to discuss is that we are going to discuss this complete Hadoop ecosystem. I'll show you what exactly the Hadoop ecosystem is going to look like. This is what is your Hadoop ecosystem. I'll come back 1 minute. This is what is the Hadoop ecosystem that we are going to see here. So if you want to understand what exactly you're going to learn from this particular course, this is something which you are exactly going to learn from this particular course. This is something that you are going to learn from this course. We'll talk about Pig. We'll be talking about Hive. We'll be talking about your H catalog. You'll be talking about your Mapreduce. You'll be talking about your HDFS, Scoop and Flume, Zookeeper, Ambari, and Woozy. These are all the things that we are going to discuss, which is going to be a 30-hour sessions that we are going to have, including practicals and 1 hour sessions starting from Monday to Friday. Okay, that's what the course is going to be discussed. If you are really interested in knowing the course curriculum, I hope Mr. Raidu has already shared to you. Mr. Raidu might have already shared to you, but you can check with him once also as well regarding this particular course curriculum. Okay,